Hello, ho, ho, ho! Yes, and welcome to our Objective 16 notes. Today, we're going to hit up part one of these notes. Objective 16 says, I can solve a system of linear equations algebraically and use systems of equations to solve real-world problems. So we're going to split this up really into 3 days. Today, we're going to focus on substitution. Tomorrow, we'll focus on elimination, and then we'll do word problems the last day. Alright, so we're going to get started today with substitution, but just a reminder, whenever we're solving these systems of linear equations, we want to find values for x and y that make each equation true. We want to find values that satisfy both of the equations. So, with substitution, there's some steps we're going to go through. Here they are. First, we're going to identify the variable we want to isolate. Now the key here is finding what variable do I have to do the least amount of things to get it all by itself. So if I'm looking at my sample problem here, negative 4x minus 8y is 0, negative 3x plus y is 7. The variable I'm going to choose to isolate in this case would be this y. Alright. Now why would I choose to do that? Well, because the only thing I need to do to get y all by itself is add 3x. So we're going to use algebra to isolate this variable. So we're going to add 3x to both sides, add 3x to both sides. When I do that, I get y equals 3x plus 7. Alright, so now that I've done that, I've isolated this y, I'm going to plug in the value of the variable I just solved for, 3x plus 7, into the other equation. Sorry, I had to read it. Into the other equation for that variable. So what I'm doing here, I'm going to take 3x plus 7, I'm going to plug it in for this y here, right? Because y equals 3x plus 7, I got that from my bottom equation, so I'm going to put that into my top equation. Alright, so when I do that, I'm going to now have negative 4x minus 8 times, and instead of y, I now know that y equals 3x plus 7. And I'll say that equals 0. Alright, so now we're going to solve this new equation we have here. Notice we only have one variable. We only have x now. So let's solve for x. So I'll have negative 4x. You distribute the negative 8, so this will become negative 24x. Negative 8 times 7 would be negative 56 equals 0. I combine my like terms and add 56 to both sides. When I do that, I would get negative 28x equals 56. Divide by negative 28. 56 divided by negative 28 is negative 2. So I found x equals negative 2. Now what I'm going to do is I'm going to plug in the value we found, x equals negative 2, into the original equation. Now notice here, I found y equals 3x plus 7. So this is when I'm going to come back and I'm going to use this equation here, y equals 3x plus 7. So I would say now that y equals 3 times negative 2, which is what x is, plus 7. Well, 3 times negative 2 is negative 6 plus 7. Negative 6 plus 7 is 1. So I found that y equals 1. We just solved for the other variable, in this case y. And now I know x equals negative 2, y equals 1. I'm going to write my answer as a coordinate pair. Remember, because this is where these lines would cross on the coordinate plane. So I'll say negative 2, comma 1. There we go. All right, questions there. If you have a question, go ahead and raise your hand. Otherwise, let's do some practice with this idea. All right, it says solve the following systems of equations using substitution. Be sure to write your answer as a coordinate pair. So, looking at letter A here, y equals negative 3x plus 7, y equals 2x minus 7. Well, notice that both of the y's are already isolated. So this is really nice. I can just set these x values equal to each other because y equals y. So that means that 2x minus 7 is going to equal negative 3x plus 3. Alright, so now I need to get x all by itself here. I'm going to add 3x to both sides. 2x plus 3x is 5x, so I have 5x minus 7 equals 3. I'm going to add 7 to both sides. 3 plus 7 is 10. So 5x equals 10. Divide by 5, divide by 5. And I find that x equals 2. Now that I know x is 2, I need to plug it in. Does it matter which equation I plug it into? No, I should get the same thing. So I'll say y equals negative 3 times 2 plus 3. So that's negative 6 plus 3. Negative 6 plus 3 is negative 3. So y equals negative 3. So I find x is 2, y is negative 3. That means my coordinate point would be 2 comma negative 3. There we go. Let's try this one here, letter B. Y equals negative 2x minus 5, y equals negative 5x minus 2. So once again, we have both of the variables already isolated, so I can just set them equal to each other here. So negative 5x minus 2 equals, what this y, equals negative 2x minus 5. Fantastic. I'm going to start by adding 5x to both sides, plus 5x. When I do that, I get negative 2 equals 3x minus 5. I'm going to add 5 to both sides, add 5. Negative 2 plus 5 is 3. So 3 equals 3x, divide by 3, divide by 3, and I find that x equals 1. So now that I know x is 1, I can plug that into either equation. So I'll say y equals negative 2 times 1 minus 5. Well, negative 2 times 1 is negative 2. Negative 2 minus 5 is negative 7. So my solution would be the coordinate point 1 comma negative 7. Excellent. Alright, let's try letter C here. Negative 2x plus 2y equals 6. Y equals 7x plus 21. So notice here, a little different than last time. They're not both set y equal, but we do have one that's already isolated, right? That y equals 7x plus 21 is already isolated. So let's use that as our substitution. So we'll say negative 2x plus 2, and instead of y, I'm going to say 7x plus 21. So 2 times 7x plus 21 equals 6. So I'll have negative 2x plus, I got to distribute here, 2 times 7 is 14. So I'll have 14x. 2 times 21 is 42 equals 6. Subtract 42 and combine my like terms here. So negative 2x plus 14x is 12x equals 6 minus 42 is negative 36. Divide by 12, divide by 12. Negative 36 divided by 12 is negative 3. So now that I know x is negative 3, I can plug that in to that original y equals 7x plus 21 equation. So y equals 7x. Instead of x, we're going to say negative 3 plus 21. 7 times negative 3 is negative 21, plus 21 is just 0. Y equals 0. So my solution would be negative 3 comma 0. X comma y. Very good. If you have a question, feel free to raise your hand. Otherwise, why don't you guys try D, E, and F on your own? Feel free to try D, E, and F on your own. Go ahead and pause the video, do those 3, and then we'll check them together, all right? D, E, and F, give it a shot. Let's see how we do. All right, let's see how we did here. So with y equals x minus 11, y equals 3x plus 5, we should have just set both of these x expressions equal to each other to figure out what x is. So how you got x might be different than I did. The important way is that we get the same answer. So how I'm going to do that is I'm going to add 3x to both sides. So I'll have 5 equals 4x minus 11. Add 11 to both sides. 5 plus 11 is 16. It's 4x divided by 4 divided by 4. And we'll find that x equals 4. So now that I know x is 4, plug that in. Y equals 4 minus 11. So that means that y is negative 7. So our coordinate point was 4 comma negative 7. There we go. For the letter D, 4, negative 7. Now looking at letter E, we have y isolated here. So let's plug that into the top equation up here. So we'll have negative 4x plus 3 times the quantity, negative 3x plus 12, equals negative 3. So negative 4x minus 9x distributing that. 3 times 12 is 36 equals negative 3. Combine my like terms, I'd get negative 13x. I'm going to subtract 36 equals negative 3 minus 36 would be negative 39. Negative 13. Let's divide that from both sides. Now tell me a negative divided by a negative gives me a positive, so x is 3. I can then plug that in, so I'll have y equals negative 3 times 3 plus 12, right? Plug it in for x up here. So 3 times 3 is 9, so I'll have y equals negative 9 plus 12, which is 3. So my coordinate points, x is 3, y is 3. So my solution would be the point 3, 3. That's where those lines would cross if we graphed them. Those are values for x and y that make both equations true. All right, one more. Letter F, y equals negative 5x minus 12, 6x minus 2y equals 8. So we have y isolated here. So let's plug it in for this y here. So we'll have 6x minus 2 times, instead of y, I'm going to say negative 5x minus 12 equals negative 8. All right, let's distribute this negative 2 here. So 6x plus 10x, negative 2 times negative 12 is positive 24 equals negative 8. I'm going to subtract 24 from both sides. So I'll have 16x equals negative 32. Divide by 16, divide by 16. I'm going to find that x is negative 2. Now that I know x is negative 2, plug that in that top equation. So y equals negative 5 times negative 2 minus 12. The negative times a negative gives me a positive, so I'll have 10 minus 12. 10 minus 12 is negative 2. Y equals negative 2, so my solution here, negative 2, comma, negative 2. Fantastic. If you have any questions, raise your hand. I'll be around. I want to make sure you understand what we're doing so far. If you're feeling confident, go ahead and continue. Let's talk about the different possibilities we could have here. So there's 3 possible number of solutions. One is one solution. Graphically, that looks like the lines intersect at one point. How does that look algebraically? Well, algebraically, we find x equals a number and y equals a number. We get a value for x and a value for y. Now, it's also possible that there's no solution. The lines don't intersect. How would that look algebraically? Well, remember, graphically, that means there's parallel lines. Algebraically, what that means is we're going to get an untrue statement. We're going to get something like 0 equals 12, or negative 4 equals 7. Something that's not true. Notice there's going to be no variable here. All right, there's no x, there's no y. Those have been eliminated. Those aren't there anymore. They've been canceled out during the operation. And then there might be infinite solutions, and that'll be when we get a true statement without a variable. That'll be something like 0 equals 0, or 10 equals 10. Notice for both of these, for both the no solution or infinite solution, these solutions have no variables in them. That's how you can tell. If there's a variable, then it's one solution. If there is not a variable in my final answer, when I simplify everything down, then it's either going to be no solution or infinite solution. It's no solution if there's an untrue statement. It's infinite solutions if there's a true statement. Alright, so let's try some examples with this new information. So let's look at letter A here. X minus 2y equals negative 2, negative 6x plus 4y equals negative 4. Now we're going to solve this and then identify if there's one solution, no solution, or infinite solutions. So let's start by identifying the variable we want to isolate. I see this x here, no coefficient. All I would need to do is add 2y to get it all by itself. So by adding 2y to both sides here, I would have x equals 2y minus 2. And that's going to be what I plug in to this equation here. So I'll have negative 6 times 2y minus 2 plus 4y equals negative 4. All right, let's distribute this out here. So negative 6 times 2y is negative 12y. Negative 6 times negative 2 is positive 12. Plus 4y equals negative 4. Combine my y terms here, and let's go ahead and subtract 12 from both sides. Subtract 12. Negative 12y plus 4y would become negative 8y. Negative 4 minus 12 would be negative 16. Divide both sides by negative 8, divide by negative 8 to get y all by itself, and we're going to find negative 16 divided by negative 8 is positive 2. So now that I know that, I'll go back into that equation that we had earlier where x equals 2y minus 2 and plug in what we found, y equals 2. So we'll say x equals 2 times y, which we know is 2, minus 2, which means x is 4 minus 2. 4 minus 2 tells me that x equals 2. All right, now let's check here. What do we know? All right, did we find x equals a number and y equals a number? Yes, we found x equals 2 and y equals 2. That tells us then that there is one solution. That one solution is the coordinate point 2, 2. One solution, 2, 2. And that's our answer here. One solution, 2, 2. Excellent. All right. Very good, very good, very good. Let's try letter B now. 3x plus 21y equals 8. X plus 7y equals negative 8. So I want to find a variable to isolate. Which of these variables would be the easiest to isolate? Probably that x right there. All I would need to do is subtract 7y from both sides. So I will say x equals negative 7y minus 8. So let's plug that then into this top equation for x up here. So we'll say 3 times negative 7y minus 8 plus 21y equals 8. Distribute the 3 into everything here. So 3 times negative 7y is negative 21y. 3 times negative 8 is negative 24. We'll have plus 21y equals 8. Well, notice here, negative 21y plus 21y would give me 0y. So I'd have 0y minus 24 equals 8. 0 times anything is just 0. So this becomes negative 24 equals 8. Do we see how this 0y is just 0? All right, well, negative 24 equals 8, and there's nothing more I can do there to simplify that. So let's see, negative 24 equals 8 doesn't have a variable, so that means there's not one solution. Is it an untrue statement? Well, does negative 24 equal 8? No, it doesn't. So this is an untrue statement. If we get an untrue statement, what does that mean? That means no solution. So this system of equations would have no solution, which means if I were to graph these lines, they'd be parallel. They'd never cross, right? Very good. All right. Looking at letter C now. Looking at letter C. 9x plus 6y equals 66. 3x plus 2y equals 22. Oh boy. Notice this one doesn't really have a variable that looks really easy to isolate. When that's the case, I normally recommend just working with the smallest number because they generally won't hurt you as bad. So with that being said, let's isolate this y here. So I'm going to start by subtracting 3x from both sides. So I'll say 2y equals negative 3x plus 22. And then I'm going to divide everything by 2. So I'll say y equals negative 3 halves x plus 11. So let's plug that into this top equation here. So we'll have 9x plus 6 times negative 3 halves x plus 11 equals 66. When we simplify this, we'll get 9s. 6 times negative 3 is negative 18 over 2x. 6 times 11 would be 66 equals 66. What is 18 divided by 2? Well, that's 9. So this is going to be 9x minus 9x plus 66 equals 66. What's 9x minus 9x? 0. So I'm left with just 66 equals 66. Notice, no variable here. Notice 66 does equal 66. This is a true statement. What does that mean? Well, if we get a true statement, that means we have infinite solutions. So let's go ahead and write that here. Infinite solutions. I-N-F-I-N-I-T-E solutions. Fantastic. Which means that if I were to graph these original lines, they would actually represent the same line on the coordinate plane. So here's 3 examples of each possibility. We have one solution with letter A, where we had x equals 2, we had y equals 2. We found the values to give us that one coordinate, 2, 2. That's where they intersect. Looking at letter B, we had negative 21y plus 21y. Those canceled out and left us with an untrue statement. That's what gave us no solution. Looking at C, we had the 9x minus 9x. Those canceled each other out, but we were left with 66 equals 66, a true statement. So that's why it was infinite solutions. All right, if you have any questions, please feel free to raise your hand. Let's do some more examples of this to really make sure we hit it home. Why don't you go ahead and do letter D on your own? Just letter D on your own. We're going to do these D, E, and F one at a time. Go ahead and do letter D. Pause the video, try letter D. When you're done, resume it, and we'll check our work together. All right, let's see how we did for letter D. Now looking here, the variable I would recommend isolating would be this y, which means I need to add 3x to both sides. So I would say y equals 3x plus 9. Let's plug that into the top equation. So negative 2x plus 4 times, instead of y, I'm going to say 3x plus 9, because that's what y equals negative 14. So, goodness, hello. I don't know how that popped up. So negative 2x plus, we need to distribute this out here. So we'll have 12x plus 4 times 9 is 36 equals negative 14. Let's subtract 36 from both sides. Negative 2x plus 12x is 10x equals negative 14 minus 36 is negative 50. Divide by 10, divide by 10. We should find that x equals negative 5. All right, and now that we know that, we can plug that into that y equals 3 times x, which is negative 5, plus 9. 3 times negative 5 is negative 15, plus 9. Negative 15 plus 9 is negative 6. So we find x is negative 5, y is negative 6. That means there's one solution, and that one solution is negative 5, comma, negative 6. That would be my answer for that one. Very good. All right. Hopefully we're feeling confident about that one. Why don't you go ahead and try letter E now? Go ahead and try to get letter E all by itself. Go ahead and try to figure out what the answer to letter E is all by yourself. And then we'll check it together. All right. Go ahead and try letter E. Pause the video and then we'll check it together. All right. So this one's a little tougher because there's no one variable that's super easy to isolate. I would recommend doing this negative x up here. There's my calculator. All sorts of things just wanted to pop out to help, but we can do this without a calculator. So if I have negative x plus 6y equals negative 13, and I want to get this x all by itself, I'd subtract 6y. So I'd have negative x equals negative 6y minus 13. And then I divide everything by negative 1, and that tells me that x equals 6y plus 13. Now with that, I'm going to plug that into the bottom equation. So I'm going to have negative 3 times 6y plus 13 plus 18 equals negative 39. Distribute my negative 3 out here, so I'll have negative 18y minus 39 plus 18y equals negative 39. Well, what do we see here? Negative 18y plus 18y is going to cancel out. I'm left with just negative 39 equals negative 39. That is a true statement, and if we get a true statement when we do this, what does that mean? That means that there are infinite solutions. Fantastic. Hopefully we're feeling confident there. Last one, letter F. Why don't you go ahead and try letter F on your own, and then we'll be done with the day. That'll be the last thing we do. Go ahead and try letter F on your own. Pause the video, try letter F, and then we'll check it together. All right, let's see how we did here. I'm going to use this negative 2y, and try to isolate it. So that means I'm going to subtract 3x from both sides. So I'll have negative 2y equals negative 3x minus 3. Divide everything by negative 2, divide everything by negative 2 to get y equals 3 halves x plus 3 halves. Okay, now with that, I'm going to, ooh boy, this is going to be ugly. That's okay. I'm going to plug that into that top equation. So negative 7x minus 3 times y, which we just found to be 3 halves x plus 3 halves equals 7. So distribute the negative 3, so I'll have negative 7x minus 3 times 3 would be 9 halves x minus 9 halves equals 7. Now, let's go ahead and make some fractions here. Let's put everything over 2. So when I do that, I'd have negative 14x over 2 minus 9x over 2 minus 9 halves equals 14 over 2. And then I can multiply everything by 2, and we'll get rid of the fractions that way. So I have negative 14x minus 9x minus 9 equals 14. Alright, because when I multiply by that 2, I will get rid of all of those. Okay, let's add 9 to both sides. I might run out of room here. 14 plus 9 is 23. Negative 14 minus 9 would be negative 23x. When I divide by negative 23 divided by negative 23, I find that x equals negative 1. Okay, so I know x equals negative 1. Let's plug that in back up here. Let's move this up top so we have enough space. So y equals 3 halves times negative 1 plus 3 halves. Well, 3 halves times negative 1 would just be negative 3 halves. Negative 3 halves plus 3 halves is just going to give me 0. So if x equals negative 1, y equals 0, I'm going to have one solution. What is that one solution? Negative 1 comma 0. That would be my solution. Took a lot of space to make it work, but we managed. All right, I think we're done for the day. We'll call that good. Go ahead and do the chat for understanding up there on the board. When you're done, I'll pass out some practice problems. I hope you all have a great time. Mr. Carter signing off. I'll see you next time.